The U.S. Navy is pushing its most powerful weapon, the Gerald R Ford, to its limits. From shockwave tests to advanced tech trials, this supercarrier is being prepared to face China's growing fleet. But can it handle the extreme conditions of modern warfare? In today's video, we'll explore these intense tests, China's advancements, and what's truly at stake in the battle for naval supremacy. The Gerald R Ford isn't just the largest aircraft carrier ever built. It's a technological marvel designed to ensure U.S. naval dominance. Weighing 100,000 tons and armed with the most advanced systems ever deployed at sea, this supercarrier can launch up to 90 aircraft and support a crew of 4,500 personnel for extended operations. One of the most revolutionary features on the Gerald R Ford is its electromagnetic aircraft launch system, EMALS. This system, designed to replace the older steam-powered catapults, uses electromagnetic energy to launch aircraft more efficiently and with less stress on the planes. For decades, U.S. carriers relied on steam catapults to hurl planes into the air. While effective, these older systems place significant strain on both the aircraft and the launch systems themselves, often resulting in higher maintenance costs and downtime. EMALS, however, changes all of that. The Gerald R Ford's EMALS system was pushed through some of the most rigorous tests ever seen. The Navy simulated chaotic battlefield conditions, everything from high winds and turbulent seas to emergency situations where multiple planes had to be launched in rapid succession. EMALS passed each of these tests with flying colors, showing that it could not only handle the demands of modern naval warfare, but also dramatically increase the number of sorties launched per day. In a high-stakes battle, getting more planes in the air faster could mean the difference between victory and defeat. And the benefits don't stop there. Because EMALS is more precise, it reduces wear and tear on aircraft, meaning that fighter jets, bombers, and even drones can stay in combat-ready condition longer. With China rapidly expanding its fleet, this increased sortie rate could be the U.S. Navy's ace in the hole, allowing it to respond faster to threats, whether in the South China Sea or other contested waters. But what goes up must come down, and the Gerald R Ford's ability to safely recover aircraft in combat situations is just as critical as launching them. Enter the Advanced Arresting Gear, AAG, system. Traditional arresting gear used hydraulics to catch planes as they landed, a process that, while effective, put immense strain on both the aircraft and the system. The AAG, however, uses electromagnetic energy, similar to EMALS, for a smoother, more controlled deceleration. This system was rigorously tested to handle the most extreme landing conditions, from high-speed fighter jet recoveries to delicate drone landings. What makes the AAG stand out is its versatility. In the future, the Navy will increasingly rely on unmanned aerial vehicles, UAVs, for reconnaissance and even combat missions. The AAG system is designed to recover these UAVs without damaging them, ensuring that the carrier can handle not only today's aircraft, but also the next generation of drones. During its testing, the AAG successfully landed thousands of aircraft, proving that it could keep the carrier operational in even the most difficult conditions. In a prolonged naval engagement, the ability to recover and redeploy aircraft rapidly will be crucial to maintaining air superiority. The Gerald R Ford's technological innovations don't stop with launching and recovering planes. The ship is also equipped with a dual-band radar, DBR system, one of the most advanced radar systems ever developed. Capable of tracking both air and surface threats simultaneously, DBR provides the carrier's crew with unparalleled situational awareness. Whether it's tracking incoming missiles, surface ships, or aircraft, this radar ensures that no threat goes unnoticed. DBR was tested under extreme conditions, simulating the kind of multi-threat environment the Gerald R Ford could face in a real battle. The system was able to track fast-moving targets from multiple directions, giving the carrier's crew the information they needed to respond in real time. In today's naval theater, where threats can come from the air, sea, and even under the water, having this level of awareness is critical to survival. With China deploying advanced anti-ship missiles like the DF-21D, which are designed to take out carriers, the Gerald R Ford's DBR will be one of the key defenses keeping this supercarrier safe. Speaking of safety, no discussion of the Gerald R Ford would be complete without mentioning its 40,000-pound explosive shock trial. In this test, a massive underwater explosion was set off near the carrier's hull to simulate a missile or torpedo strike. The goal? To see how the ship would hold up under a direct hit. The explosion was powerful enough to create a 3.9 magnitude earthquake, but the Gerald R Ford weathered the blast with minimal damage, needing only 20% of the expected repairs. This level of resilience is vital, especially with the rise of anti-ship missile systems being deployed by nations like China. The Advanced Weapons Elevators, AWE, on the Gerald R Ford are another critical piece of the puzzle. These elevators are designed to transport massive amounts of ammunition from deep within the ship to the flight deck, where it's loaded onto aircraft. In combat, the ability to quickly rearm planes can make all the difference. The AWE system was tested under high-stress conditions, proving that it could deliver 20,000 pounds of munitions rapidly and efficiently. This ensures that the carrier can keep a high tempo of operations during extended engagements. What makes the Gerald R Ford truly stand out, though, is its ability to stay at sea for extended periods without resupply. Powered by two Bechtel A-1B nuclear reactors, the ship can operate for over 20 years without refueling. This level of endurance allows the Gerald R Ford to project power across the globe, staying operational in contested regions like the South China Sea for months on end without needing to return to port. All of these innovations combine to make the Gerald R Ford not just a powerful weapon, but a force multiplier in the face of modern threats. With China building its own carriers and investing heavily in missile technology designed to counter U.S. carriers, the Gerald R Ford has been put through the most extreme tests to ensure it remains the cornerstone of U.S. naval dominance. While the Gerald R Ford faces extreme tests, China's rapidly expanding navy is making bold moves. They've even built a replica of a U.S. carrier for missile strike practice, signaling their ambitions to challenge U.S. dominance. But how is China's growing fleet reshaping global power? China's naval ambitions are fundamentally shifting the balance of power in the Pacific and beyond. Over the past decade, China has rapidly grown its navy, now boasting over 350 ships, making it the largest navy in the world by number of vessels. But it's not just about the size of their fleet. It's about the technological advancements and aggressive strategies they're implementing. The Type 003 Fujian, China's newest and most advanced aircraft carrier, is the cornerstone of their push toward global naval dominance. With its electromagnetic catapult system, EMALS, a feature previously only seen on the Gerald R Ford, the Fujian represents a major leap in capability. This advanced system allows for faster and more efficient aircraft launches, giving China the ability to project air power farther and faster than ever before. At 1,037 feet long and weighing 80,000 tons, the Fujian is a technological marvel, designed to rival the Gerald R Ford in both capability and strategic importance. But it's not just one carrier. China's plan to build a 6-carrier fleet by 2030 marks their ambition to challenge U.S. naval supremacy on a global scale. Alongside the Fujian, China's fleet includes destroyers, submarines, and frigates, each designed to support their growing carrier strike groups. These ships, combined with China's advanced missile systems, make their naval expansion a critical concern for U.S. defense planners. At the heart of China's naval strategy is control over the South China Sea. This region is one of the most strategically important waterways in the world, with trillions of dollars in global trade passing through each year. By controlling this region, China can not only exert influence over global trade, but also extend its military reach deep into the Pacific. To cement their control, China has been building artificial islands, fully equipped military bases that give them a significant advantage in any conflict over this crucial territory. These artificial islands aren't just for show. Armed with anti-aircraft missile batteries, radar systems, and airstrips, they form a key part of China's anti-access area denial strategy. This strategy is designed to keep US and allied forces out of the region by creating a defensive barrier that is difficult to penetrate. At the core of this strategy is the DF-21D missile, often referred to as the carrier killer. The DF-21D is a ballistic missile specifically designed to target and destroy aircraft carriers like the Gerald R Ford. With a range of over 900 miles, it gives China the ability to strike US carriers before they can even come within operational range. This missile's ability to adjust its trajectory mid-flight makes it incredibly difficult to intercept, posing a serious threat to any US carrier operating near China's shores. The DF-21D, along with its longer-range cousin, the DF-26, which can reach US bases as far away as Guam, forms the backbone of China's carrier denial strategy. But perhaps the most shocking signal of China's intentions is their construction of a full-scale replica of a US aircraft carrier in the Taklamakan Desert. This replica isn't just a prop. It's used for missile strike practice, showing that China is actively preparing to target US carriers in a potential conflict. The message is clear. China is preparing for a future where they directly challenge US naval dominance, and they're doing it with precision. This aggressive expansion signals a shift in global naval power. While the US Navy has maintained uncontested superiority for decades, China's rapid buildup, paired with their carrier-killer missiles and artificial island fortifications, threatens to upend that balance. China's strategy is designed to create a no-go zone for US carriers, keeping them at bay and giving China control over critical maritime regions. With 6 carriers planned, China is on track to challenge the US, not only in the Pacific but also in the Indian Ocean and potentially further afield. Their goal is clear: to build a blue water navy that can project power across the globe, rivaling the US in every theater of operation. This rapid expansion and focus on naval power has raised alarms in Washington, with defense planners scrambling to counter the growing threat. However, China's advancements aren't without their limitations. While their fleet is expanding, they still face challenges in matching the technological sophistication of the US Navy. Their carriers, including the Fujian, are powered by conventional fuel rather than the nuclear power that drives US supercarriers like the Gerald R Ford. This limits their operational range and the time they can stay at sea without refueling. Moreover, China's experience in operating carriers is still limited compared to the US, which has been deploying and perfecting carrier operations for decades. Still, the rapid pace of China's naval expansion is impossible to ignore. They're not just building ships, they're constructing a blue water navy capable of challenging US dominance across the globe. The real question isn't if China will become a global naval power, it's how soon. With every new carrier launched, every carrier-killer missile deployed, China is moving closer to redefining the balance of power at sea. China is advancing at an unprecedented rate, but the US is already preparing countermeasures that could shift the balance of power once again. Let's take a look at how the US Navy is staying ahead in this high-stakes race. China's rapid naval expansion is undeniable, but the US is already preparing countermeasures that could once again shift the balance of power. Unmanned systems, laser weapons, and hypersonic missiles are at the forefront of the US Navy's response to ensure it stays ahead in this high-stakes race. One of the key tools in the US arsenal is the MQ-25 Stingray, an unmanned aerial refueling drone. This drone dramatically extends the operational range of US carrier-based aircraft, enabling jets to strike deeper into contested zones while keeping US carriers, like the Gerald R Ford, out of range of China's carrier-killer missiles. By keeping planes in the air longer, the MQ-25 offers US forces a significant strategic advantage in far-reaching combat scenarios. In addition to unmanned aerial systems, the US is also turning to unmanned underwater vehicles, UUVs, to counter the growing submarine threat posed by China's expanding fleet. These UUVs, like the Orca X-Love, are designed to patrol vast ocean areas autonomously, identifying and neutralizing enemy submarines before they pose a threat. They provide surveillance and mine-laying capabilities, extending US naval power beneath the surface without risking human lives. In contested waters like the South China Sea, these advanced underwater drones are a game changer, allowing the U.S. Navy to maintain a technological edge in submarine warfare. The U.S. Navy is also turning to laser weapons to defend against modern missile threats. The Helios system, a high-energy laser designed to target drones and incoming missiles, gives U.S. ships a near-infinite supply of defense. Unlike traditional missile interceptors, which rely on finite stockpiles, laser systems are powered by the ship's energy supply and can engage threats at the speed of light. With China developing more sophisticated anti-ship missiles, laser technology is a crucial part of protecting U.S. assets in contested regions. But perhaps the most pivotal advancement is in hypersonic missile technology. Capable of traveling at speeds over Mach 5, these missiles can strike targets with extreme precision and little warning. The Conventional Prompt Strike (CPS) system allows the U.S. Navy to deploy hypersonic missiles from submarines and destroyers, enabling rapid strikes on high-value targets such as missile launchers, command centers, and air defense systems. In a potential conflict with China, these hypersonic weapons could overwhelm defenses and deliver decisive blows before the enemy can react. These unmanned systems, laser defenses, and hypersonic missiles form a three-pronged countermeasure strategy to keep the U.S. Navy dominant. While China continues to expand its fleet and refine its carrier-killer missiles, the U.S. is banking on cutting-edge technology to outmaneuver and outpace its rival. The race is far from over, and while China may be advancing quickly, the U.S. is using these next-gen technologies to stay ahead and maintain its critical first-strike capability. China's ambitions are clear, but so is the U.S. Navy's resolve. The future of naval warfare will depend on who can innovate faster and deploy these technologies most effectively. The race for naval supremacy between the U.S. and China is heating up, but with cutting-edge technology, the U.S. Navy is ready to meet the challenge. If you found this video insightful, don't forget to subscribe and hit the notification bell for more in-depth content on global military strategies.